after the chemist and physicist Robert Boyle, which he produced the original law in 1662. It states that for a fixed amount of an ideal gas to be kept at a fixed temperature, pressure and volume are inversely proportional. This practically means that, let's say if you increase the volume of a closed object, it will lower the pressure because the particles inside will have more room to go around, which will lessen the pressure. Is it going? Alright, so according to Boyle's law, this is equation to show the inverse relationship between pressure and volume. It proves that if volume increases, pressure decreases, and vice versa. If volume decreases, pressure increases. So let's say we have a closed container of 5 liters, which will be the first volume, and the pressure inside will be 1.8 atmospheric pressure. If we increase the volume of the closed container to 10 liters, what will happen to the pressure? Will it increase or decrease? Well, according to the law, pressure should decrease, so we plug in our numbers to prove this. Our result for the new pressure is 0.54, which is lower than the first pressure, and this makes sense because we increase the volume, which means the gas particles will have more room to go around, which decreases pressure. And this drawing right here visualizes what just happened in the equation, but instead, it's not a closed system, and we'll have one small opening, which is more realistic to what happens in our body. So the container is 5 liters, just like the problem, and inside the pressure is 1.08, and the pressure inside the box is equal to atmospheric pressure. Then we increase the volume to 10 liters, and now the pressure is increased to 0.54 due to the extra space that they have to go around in. But now that we have an opening at the box, air from the atmosphere will rush inside because the pressure inside the box was decreased. And as we know, air will travel from higher concentration to lower concentration.
In physics, Henry's law is one of the gas laws by William Henry, formulated in 1803. This law stated that at a constant temperature, the amount of given gas that dissolves in a given liquid is directly proportional to the partial pressure of that gas in the liquid. As you can see, this is a container of a solution with gas particles. The more pressure that is exerted on the container, the particles will go into the liquid solution. There's more particles here. And then less pressure will make sure that there's a lower concentration of the gas in the solution. For Henry's law, the formula that we use is C1 over P1 is C2 over P2. And C1 would be the initial concentration of the gas in a solution, and P1 is the initial pressure exerted on the solution. So using the formula, we use the first concentration, which is 0.44, over the 150 for the pressure, equals the second concentration, which we don't know, over the pressure. The answer for the second concentration would be 0.15 grams of oxygen for 100 milliliters of a solution. This means that because we lowered the pressure, it directly correlates that the concentration of the gas in the solution will also be lowered. So this is lowered. Yep.
Dalton's law of partial pressure. This empirical law was observed by John Dalton in 1801, which states each gas in a mixture contributes to a proportion of a concentration of a mixture. To dumb that down a bit, for me at least. To use this law, you have to find the percentage of a gas within a mixture. For example, air. Air is not only made of of only oxygen. It's a mixture of gases. So, example, air is made of 21% of oxygen, 70% of nitrogen, and 1% of other gases. And as we know, 1 atmospheric pressure equals 760 milliliters of mercury. So to use Dalton's law, you have to use the atmospheric pressure and multiply it by the percentage of oxygen. And when you solve that out, it equals to roughly about 159.6 millimeters per mercury, which means that oxygen is separate, partial pressure in air is 159.6 millimeters per mercury.
So what do all these laws have to do with the body? For Boyle's, it has to do with breathing. So during inhalation, our inspiratory muscles contract. So this is the diaphragm, and during inhalation, it flattens out, which increases the volume. And since the volume is increased, the pressure decreases, which causes pressure inside to be lesser than atmospheric pressure, which will cause pressure from the outside, which is from our mouths, like to rush inside until equilibrium is reached.
So you may be thinking that you'll need to learn Dalton's law of partial pressure. Well, you're wrong, because Dalton's law of partial pressure reveals how the oxygen and carbon dioxide behave as a mixture of a gas and alveoli. Partial pressure will always flow from greater concentration to a lesser concentration.
The movement of partial pressure will be explained by Henry's law. This law helps to understand the movement of gases from the alveoli to the blood. The pressure of oxygen is higher in the alveoli, therefore the gas is forced into a liquid, which in our body would be blood.